Hi dear students, we are going to study about the dot product of vectors. What is dot product of vector? Or we are not using directly product of vector because you cannot directly multiply two vectors because this has magnitudes also. Vectors has magnitudes, that's why it's not possible to multiply. So multiplication between them, u1 u times v, has special formula, which is you are multiplying the corresponding components and you are adding the results to each other, and this is called dot products. Here is the formula: u vector times v vector if you multiply by each other, which means that u1 times v1 plus u2 times v2 it's going to be. So if we solve this question here, find the dot product of given vectors, which means that if I multiply u times v, I'm going to apply the formula directly. I'm going to write u1 times v1, which is minus 2 times 5 here, plus 3 times 4 it has to be. So u vector times v vector dot product, u dot product v vector is equal to minus 10 plus 12. So u dot product v vector is equal to 2, it has to be. And here, if we continue with the other example, here only it is given in standard vector form, so I can rewrite the vectors in this form again, which is equal to minus 1 and 1. Then here v vector, it's going to be equal to 5 and 1. And then it's going to be easy for me to multiply. Without converting also I can multiply, but I would prefer to convert firstly to coordinate form, then multiply. So minus 1 times 5, it's going to be minus 1 times 5 plus 1 times 1, it's going to be here. 1 times 1, it's going to be, which is equal to minus 1 times 5 minus 5 plus 1 times 1, it's going to be equal to 1. So the answer is minus 4, which is u dot product v, it's going to be equal to minus 4 here. So results also can be negative in this case. Okay, now we are going to continue with the properties of the dot product. From the definition of dot product, you know u dot product v is equal to v dot product u. It might be from the properties of addition and multiplication, you know, the components are multiplied, and both of them, addition and multiplication, since it has commutative property, it's normal to have commutative property for the dot product also. But here I think the book's mistake, the associative property, this is not associative property, this is distributive property. This is distributive property. It should be multiplication dot product over addition. Normally you can distribute like this. And the third one is multiplying the dot product result by scalar, or you multiply any vector by scalar, then you will make the dot product. It is same. And the third one, and the important one here, when you multiply the u vector by itself, you will get the distance square of u. So I'm going to find the here I'm going to do this property on this exercise. Let's have a u vector is equal to 2 and minus 2. So what is the distance of u? Find the length of u by using the dot product, which means that u times u vector here, which is equal to 2 times 2 plus minus 2 times minus 2, it has to be. I don't know why I have drawn this one. I need to clean this part here. Yes. And then the result it's going to be equal to, u distance square, which is equal to 4 plus 4 is equal to u distance square, u vector's distance, and it's equal to 8. So u square vector is equal to 8. It should be, and you can get the result by getting the square root of 8, and that makes the distance of u, it should be equal to square root of 8, or it is equal to 2 root 2. It might be. By the way, here when you get the square root, you should get positive and negative, but since it is distance, we are going to get only the positive one. Okay, let's continue with another theorem here, the dot product theorem. Here, let theta be angle measured between two non-zero vectors u and v. So dot product of u times v, u and v, is equal to the length of u times length of v times cosine theta. If we derive this formula, if we leave the cosine theta alone, you should get this one down here, u times v dot product. Here, what I'm trying to tell is this one. If you're looking for only cosine theta, u times v vector here times divided by u length times v length, it's going to be. So I'm going to continue with these exercises to explain this one, this case. Firstly, I have to find the length of u and v here. Then I'm going to continue. Let's find the length of u. It's going to be equal to, because in my formula, before starting to length of u, again I'm telling the formula here, cosine theta, it should be equal to u times v divided by u length times v length. Or I can write like this directly. Cosine theta is equal to u times u dot product v and the distance of u vector times distance of v vector, it's going to be. So it's equal to here directly 2 times 5 here, this 5, and plus 5 times 2 all over u vector square root of 2 square plus 5 square plus square root of 5 square plus 2 square. It has to be, this is the v vector, length of v vector. It is not plus, I'm sorry, it is times again. Here, whatever we are going to find, since it's going to be same as you see from the numbers, 2 square plus 5 square, it's going to be 5 square plus 2 square. So you can get rid of this powers also, but square roots also, but let's continue with the directly. This is 10 plus 10 divided by 2 square is equal to 4 plus 25 plus, I'm sorry, times 4, not 4, this time 25 plus 4 it's going to be, which is equal to 20 divided by square root of 29 times square root of 29, which is equal to 20 over square root of, not square root of, square root of 29 times square root of 29. It should be equal to 29. We know this one from the second grade informations. So the answer is 20 over 29. Cosine theta is equal to, cosine theta is equal to 20 over 29. It's going to be. Here in the second question, it says find the angle between them. So here, as I understand from this question, the angle is known angle, which is equal to 45 or 30 or 60 or 0 or 90 degree. It should be, these are the known angle for us. So one of them, it must be. So cosine theta, this time I'm not going to write the formula directly, I'm going to start the formula. 1 times 2 plus root 2 times 2 root 2 all over 1 square plus root 2 square in the square root times 2 root 2 square, 2 square plus 2 root 2 square. It's going to be, here it's going to be equal to 1 times 2 is equal to 2. Here root 2 times root 2, it's going to be equal to root 4. So plus 2 times root 4, which is equal to 2. Down it's going to be equal to 1 plus root 2 square is equal to 2 times divided by root 2 square is equal to 4. 2 root 2 square, it's going to be equal to 4 times 2 plus 4 times 2, which is equal to here 2 plus 2 times 2 divided by root 3 times root 4 times 2 is equal to 8, and times plus 4, it's equal to root 12, which is equal to 2 plus 4 divided by root of 3 times 12, which is equal to 6 over root 36, which is equal to 6 over 6, that's equal to 1. If cosine theta is equal to 1, if cosine theta is equal to 1, we know that cosine theta from the unit circle, cosine theta is equal to, if theta is equal to 0, then cosine theta is equal to 1, which means 0 degree here, which means angle is theta is equal to 0, it has to be. So this is the also known angle that I have written here. Okay, this is the last one. Actually, it is related with the previous one. Here, if two non-zero vectors u times v are perpendicular, u times v dot product, it should be equal to 0. Why it's like that? Let me explain to you. From the previous formula here, which is equal to u times v cosine theta is equal to u length times v length of u and length of v. If it is equal to, if the angle is equal to theta is equal to 90 degree, if the theta is equal to 90 degree, then cosine 90, it should be equal to 0. So if this is equal to 0 and this expression a over b, whatever, it's equal to 0, b shouldn't be equal to 0, which means that a, it should be equal to 0 here, and a is this value. So here is a proof of the formula. If two vectors are perpendicular to each other, dot product, it should be equal to 0. Let's continue with the exercise and finish the lesson here. Here, u vector times v vector, we found that 6 times 1 plus minus 2 times 3, which is equal to 6 minus 6, which is equal to 0. We understood that from this product, the angle is between, so theta is equal to 90 degree, which is perpendicular. And here, on this part, if are the vectors perpendicular, if the result is not equal to 0, u times v is not equal to 0, then it is not perpendicular, but let's check is it or not. So it's going to be equal to 3 times 2 plus 5 times minus 6, which is equal to here 6 minus 30, which is equal to minus 24, is not equal to 0, so not perpendicular. Perpendicular, I'm going to abbreviate here.